Okay, video has started, and I'm not muted, and alright, today we are going to go for only half an hour until 1 o'clock, and then the exam opens up at 1:15, and it goes till for an hour and a half to 2:45, and we will start with this practice quiz. And we're going to 4.1, multiplication with exponents and scientific notation. And without a calculator, just get those following answers. I'll give you a minute or so here with these. Okay, about 15 more seconds. So, if it's been a while, my first instinct on here will be to put 9. But that's not right. It's 3 times 3, 3 times. And 2 of them make 9. 9 times 3 is 27. And 2 to the 5th, I count on my fingers. I put my thumb out and I say 2. And then I go to the next finger and I double it to 4. And then to 8. And then to 16. And then to 32. And I'm on my pinky finger. So 32. Just refresher on exponents. And 10 to the 6th. Well, anytime you multiply 10 times 10, that's going to be 1 with 2 zeros. Multiply by another 10, that's 1 with 3 zeros. So all you have to do is count out the number of zeros when you're multiplying by 10 or 10 to a power. 6 of these. And there's 1 with 6 zeros. And then we'll put the commas in there. So it's 1,000,000. And when you multiply by 1 with any number of zeros, the fast way to do this is you just move the decimal point. You move it 2 places to the right, and then you got to insert another 0. So it's 170. And the same thing here, you just move the decimal place 2 places to the right. Oops, it's 8736.4. Okay, and then you just count up all your zeros. 1, 2, 3, 4, 5. And we get this. Alright, and let me have you give me a little feedback. I want you to use this little protocol for the feedback, and come back here, put it right here. So I was having you give me information on whether you got it right or not. Don't bother with that. Just give me the review. Rate the review activity. The problem was too easy. Reviewing this problem is no longer necessary. So number 1. The review reinforces concepts and procedures, and that's 2. And 3, the review is giving me new insights, and I'd like you to just write something down each time, as well as give me a number. Sometimes what's written down really resonates and really clarifies. That's something that was difficult, or another student might relate to that as well. All right, so go ahead and give a little feedback for the practice quiz. And go ahead and hit enter. Let's go. That's it for the practice quiz, because we're so short on time today that we're going to go right into multiplication with exponents and scientific notation and terminology. So this number here is called the base. Call this the exponent. And this the result. Okay. So then we're going to go to the rules for exponents. So, true or false? 10 to the second times 10 to the third is equal to 10 to the sixth. And let me just check before we go into groups on this. Go into your group chat, type in hi. Let's just check. Group leader, make sure the spokesman for the day knows who they are. And group 1, how many of you are here today? Group 2, how many of you are here?
There's 2 of us.
Great. Group 3?
There are 3 of us.
Group 4?
There's 3 of us.
Group 5?
It looks like there's 2 of us, but I see other people in our class that are online that didn't say hi.
Okay, maybe they're just not at the computer right now or something. Okay, all right, so we got groups 2, 3, 4, 5. All right, so go ahead into your group chat and type in T or F for whether you believe this to be true or false. And just use your instinct. You know, it seems reasonable or does not seem reasonable. T or F. Go ahead and hit enter into your group chat and note the other results. And group 3. What did you have? What do you see? How many trues? How many falses?
We all said it was true.
You all said that this is true.
Yeah.
Because 2 times 3 is 6. It really does feel like this is true. Multiplication and this. Alright. But it appears to be true. But let's look at it like this. 10 squared is really 10 times 10. This multiplication sign, I'm going to bring it straight down here. Make it look different than that. They mean the same thing, but just makes it look a little different. And then 10 cubed is 10 times 10 times 10. Now from the practice quiz, we saw when you're having like 10 to the 6th, that's 1 with 6 zeros. or you just count up the number of zeros. So if we just count up the number of zeros, we see here, what do we get? 1, 2, 3, 4, 5 zeros. This is really 10 to the 5th, or 1, 2, 3, 4, 5 zeros. While this side, 10 to the 6th, is 1 with 6 zeros. And that's 1,000,000, and that's 100,000. These are different. This appears to be true, but it's false. All right. Now that's kind of a mouthful there. Let's go to part B. X to the 3rd times x to the 4th equals x to the 12th. Is that true or is that false? Go ahead to your group chat and type in whether it's T for true or F for false. And observe the other results. All right, group 5, what do you say on this one?
We said we have both answers, false and true, but no idea why.
Okay, it's question mark. Not clear which one or why. All right, so let's look at it more in detail. Let's go. What does x to the 3rd really mean? X times x times x. You don't even have to put the dots. If you put x's next to each other, it means they're multiplied. Times x to the 4th. It's 4 x's. Now, what does x to the 12th mean? Well, that's pretty clear. It's 12 x's. I'm going to put them in groups of 4 so that I can kind of count them easy. But it's 12 x's altogether. Does this look like the same thing? Ooh, no. There's a lot more red x's than there are blue x's. How many blue x's are there? There's really 7 of these. The left-hand side is really x to the 7th. The right-hand side is x to the 12th. 12 x's, and this is only 7 of those x's. The left-hand side up here was 5 10s, if you wrote them all out. While the right-hand side, if you wrote them all out, was 6 10s. It had an extra 10. That's why this one was 1 0 more than what we had over here. So that was 1,000,000 versus 100,000. All right, we're starting to see a pattern here. That this feels like you should be able to multiply 3 and 4 to get 12, but if you do that, you're wrong. Feels like you should be able to multiply 2 and 3 to get 6, but if you do that, you're wrong. It's false. False. Rules for exponents. Rule 1. It says x to the a times x to the b is either x to the a times b, or it is x to the a times x to the b is x to the a plus b. So, which one of these two rules is the correct rule? And you can look back at the previous examples, and so let me give you a moment to think about it individually. Then go into your group chat and put a 1 if you think it's the first equation is the right rule, or a 2 if you think it's the second equation is the right rule. look at the other responses. All right, group 2. What do you have?
We have the second one and also the first one.
One of the first and one of the second.
Yeah.
All right. So let's look. The first one seems to make more sense to me because this is multiplication right here, and you're multiplying the A and the B. So this one feels good to me. The second one doesn't feel right because look at, there's no addition. It's x to the A times x to the B. Why in the world would you add the A and the B together? Well, turns out it's not the one that looks right. It's the one. It's this one. The real answer, let's go back to these. The real answer, x to the third times x to the fourth. Well, if we count up the number of x's, x to the third is 3 of them, times x to the fourth, that's 4 of them. Count them all up, that's x. It should have been x to the 7th. And how would you have gotten 7 from 3 and 4? Adding them up. It's this. The real answer up here, 10 to the 2nd is here, 10 to the 3rd is here. It's 1 with 5 zeros. This should have been 10 to the 5th. How do you get 5 from the 2 and the 3? You add them together. Now, when I first learned this rule was really confusing for me. Because I said to myself, holy cow, there's no addition in the problem. But yet I add the two numbers. It seems crazy. But when I visualized it, x cubed, xxx, x to the 4th, xxxx. There's 7 of them, I could count them. And it started to make some sense to me. So, that's the rule. And we say this rule in this way. When we're multiplying, and the bases are the same, we add the exponents. So let me write that out. When multiplying, if the bases are the same, add the exponents. It's this multiplication kind of magically turns to addition with the exponent. And the reason why that is, it has to be because we got tired of writing things like x, 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 x. And we said, let's just make this shortcut notation x to the 4th. Now there's no 4 in there, it's just kind of an abstract property that there's 4 of these x's. And so it's just the nature of this shortcut notation that some strange things are going to happen. When you use this shortcut notation, when you're multiplying, you wind up adding the exponents. The other strange thing that might seem strange to you is that when you multiply these two things, you don't multiply the bottom numbers together. It's not like x, you write double x to the 7th. You just write that x one time, the base one time, and then you add those two exponents. It's just because of this shortcut notation for exponents. Alright, now that's one of the properties. We're moving really fast today because we're just, we only got half an hour. We're going to go to this other property. X to the 2nd to the 3rd power. True or false? Does that equal x to the 5th? So, take a moment to think about that. Go into your group chat, type either T or F. Go ahead and hit enter. Group 4, what do you see for the entries for this?
We've all got false as the answer.
False. And any idea why it's false?
My guess would be that since the 2 is on the outside of the parentheses, you'd have to multiply the whole thing twice.
So what should it be? 10 to the what?
It'd be like, I don't know.
It's tricky. All right, let's look at it. We can expand this. Just come straight down. What does 10 to the second mean? It means multiply the 10 times itself. What does anything to the third power mean? It means multiply whatever's in the parentheses times itself 3 times. Now these parentheses just mean multiplication. They're the same as having a dot in between. So now let's count up all the 10s. How many 10s do I have? 1, 2, 3, 4, 5, 6. So this is the same as 10 to the 6th. So this, the 2 and the 3, you don't raise 2 to the third power. So by the way this is written, you might not be able to tell. It's this. The powers are getting higher and higher. Okay. And we wound up just multiplying those two things together to get the correct answer. And so over here, if you raise one base to 2 consecutive powers, it makes sense. I'm going to guess, I think this is x to the 6th, because I wound up having to multiply those two over here. I think I multiply over here. Let's see if that makes sense as far as expanding it out. What does x to the 3rd really mean? It means 3 x's multiplied together. What does anything squared mean? It means whatever you have is multiplied by itself. And then how many x's are there all together? 6. Okay, so we wind up with 2 rules for exponents. When you're multiplying and the bases are the same, we add the exponents. And here we have a fancy way of saying the second one. We just say power to a power multiply. So the first one, we repeat what we said before. When multiplying, if the bases are the same, add the exponents. And then if you're raising one base to 2 different powers, power to a power, multiply the 2 powers together. That allows you to do a bunch of things. Okay, so we got a couple problems real quick. Let's work these out. So if I'm going to expand this out and then condense, notice it's all one term. There's no addition, subtraction, or equal signs. So I can just regroup them. I can put the 2 and the 3 out front. I can put the a squared and the a to the 4th in the back. The 2 times the 3 makes 6. A squared is the same as AA. Let's put a little parentheses around this. A to the 4th is 4 a's. And And then this is 6a to the what power? Well, I just count up all the a's. 1, 2, 3, 4, 5, 6. So notice I multiplied the numbers, 2 times 3. I added the exponents, 2 and 4 added together to become 6. I didn't have to go over this middle step. This is called expanding out and writing it without exponents. I could have gone right from here straight to here, but even if you go right from here to here and you don't write down this middle stuff, what the really good math students tend to do is they tend to visualize. I visualize AA and 4 A's here, and I see in my mind's eye 6 A's, and that's why I get A to the 6th. So, more so than memorizing, because if you just try to memorize all these rules, when you multiply you got to add them, you'll wind up getting rule bound. It'll be too many rules to keep track of. If you have some way to kind of visualize it though, and it makes sense, then you hang on to it for years and years and years, and it's not difficult. All right, let's do B. Anything to the 4th means this thing gets multiplied by itself 4 times. That's supposed to be a square. Alright, so we have that. Now we can rearrange them, put all the 2's next to each other, and then count up with my fingers. My thumb is 2, double it as I move to the next one, 4, and then 8, and then 16. It's a 16, and now this time I'm just going to visualize, I'm not going to write them out. I see XX, 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 and how many X's altogether? There would be 8 X's. Okay. Now, this could have also been done by this method. There's an unwritten 1 as the exponent on the 2. And when you distribute that 4, now this is all one term inside here, so you can distribute it. You would get 2 to the 1 times 4, because power to a power you multiply, times x to the 2 times 4. This is 2 to the 4th times x to the 8th, which is, and 2 to the 4th is 16, 16x to the 8th. So we could have done it one of 2 different ways. Expanding it out, or just kind of distributing it and coming up with our answer. And we have a minute left. Very quickly, I want to go through we'd done this way back. This means repeat the negative sign 4 times. This, the 4th, does not extend to the negative sign. The exponent happens first, so it only happens to the 2. This is negative 16, while this is positive 16. And fractions, we can raise this to the 3rd power. And then negative times negative times negative is negative. 2 times 2 times 2 is 8. 3 times 3 is 9, times another 3 is 27. We get that result. So we can take fractions to powers. Scientific notation. Well, we've run out of time. I'll cover this next time. So when you get to the scientific notation problems, you have 2 choices. You can read about it in the textbook and do those problems, or you can wait Waiting will be fine if you can do all the other parts. All right, so the homework is 4.1. And if we look on the website for 102, in the modules, you see when we get down, there was chapter 1 test. Here's the chapter 2 test. That will open up at 1:15. So you have a 15-minute break. So that's how you do to go to get started. And it has to be uploaded by by 2:45. You have an hour and a half. And yes.
Sorry, I didn't mean to interrupt, but it still says on my end of the canvas 2:15. It doesn't say 2:45.
Mine says 2:45. Maybe when you open it. And if it does continue to say 2:15 for you, don't worry. You could email it to me if it was after. You know.
Okay. Thank you.
And if something comes up and some emergency and you have to tend to it, and you have to email it to me later, that's no problem. Just email it to me and just explain what happened. Okay, and the other thing I wanted to point out is as you go on for the rest of the semester, you're going to see assignments in here, but you're not going to see any more practice or spot checks. The spot checks are done with now. The reason for that has to do with Canvas. It had a limitation on the number of assignments I can have. And at about the halfway point, it said, boom, and it wouldn't accept any more assignments. So I had to stop doing the spot check. So I'm going to give you a little pep talk here for the remainder of the semester. And in future classes, something to really keep in mind. You've had the experience now of what it's like to be doing an assignment as soon as it's assigned. And then you're able to ask questions about it and cement your knowledge. And it's something to really consider and think about, is if in future math classes or in any other class, is whether that's a habit that you want to establish and keep up. Because it can take you a long, long way. Even in some topics that are very, very difficult, is getting on them right away and then having the time to be able to, get the help you need or utilize the resources you need to get it. All right, so we will stop here. I'm going to turn off the video and